Agentic AI simulation, more value, less hype. It's grounding understanding and the practical benefit. Some DB engineers imagine the AI can do anything for them. Others distrust the technology associated with the magical claims. Engineers must reveal reliable and a precise product, relying on a comprehensive and accurate simulation to prove the quality of their project, not magical promises. As between the unbounded optimism and unbounded skepticism, where does reality lie? Can AI in a simulation be trusted as hand-free technology, or must you manually reconfirm the simulation to verify its claim? How much time does it really save? Can AI enhance the quality of the result, or is it just a time saver? In this article, we aim to answer how agentic AI for verification can help in all these areas, not with the magic, but with the common sense understanding of what it is doing and how that fits into the discipline engineering process you already practice. Our insights are based on experience with the customer using various AI and an innovative agentic AI solution on live project. Pulling back the curtain on AI, the discoveries and optimizations AI can offer can sometimes seem magical, but the magic is largely thanks to the massive data scale that this type of analysis can access. Despite our experience as humans, we can only wrap our brains around the limited amount of data to draw conclusions. However, AI can consume the huge volumes of data looking for trends and anomalies. As for designers, DV engineers have different ways of dealing with the complexity and are already very successful without AI. How do they do this? And what is different now? These engineers are skilled at forming with some imprecisions, abstraction of a higher level behavior from trends they see in data, and can very successfully use those abstractions to draw conclusions. Abstraction is exposed to the human strengths. AI works quite differently. It doesn't abstract but instead of dives into detailed data, applying statistical analysis to look for a pattern across the gigabytes of information in multiple formats. This is an AI's super strength. Humans excel at seeing big patterns. AI will see big patterns too, but it excels at seeing rare patterns. The driver for this change is never-ending growth in design and region. Regulation sizes are made on relenting schedules, thanks ironically to the demands of the AI content in hardware. Now we need to manage both large scale and rare behaviors. To keep up, we must continue raising our DV game, leveraging human expertise in design and DV and AI-based expertise in a rare event. This is a collaborative partnership in which you'll find the AI contribution very familiar and complementary to what you already do. AI-based testing builds on constraint random CR testing. CR generates multiple tests around the prototype test by randomizing input within DB-defined constraint, probing a wide range of scenarios than a direct test developer can easily conceive. This method aims to expose more failure free signature with little added effort. Randomization is very effective in finding such a signature and improving coverage in early stages of design. However, as the design stabilizes despite randomization, redundancy in testing increases rapidly while still adding little to important areas with low coverage. Further, increasing coverage depends on some more creative approaches to test those areas thoroughly. AI-based testing preserves what is good about randomization with DV-defined constraint, but is more surgical in attacking goals. Throwing a strain drawing on training, it adds a new constraint to bias randomization toward select a failure signature of rarely the hit the coverage bins. This is the core of the complementary contribution that AI can make to DV training and core method. At the most basic level, training examines the randomization solver schedules for each regression run and correlate that through a multi-layer network with coverage being hit and failure signatures. Each training starts from a scratch or analyzed against one of your standard regression suits. Based on this training data, it's possible to establish the correspondence between a given failure signature or low coverage bin and related random stimuli. For a particular objective, say generating more tests around a particular failure signature, a new set of the constraint random tests can be generated. Rarely new constraint on the top existing DV constraint to zoom in around that objective. Randomization ensures that this new set of the test will prove around targeted behaviors, looking for related failures or cover opportunities. The training method is quite different from that of a large language model, LLM training. LLM trained on a massive and widely distributed data set based on a largely fixed natural language structure, vocabulary, syntax, and etc. In simulation, the language RTL may not be changed. The design and test benches change significantly through the development. For simulation, training must start from the scratch on your design and will generally be updated every couple of weeks or so. As a result, AI models built for simulation are not Ask Me Anything engine. They work with a much more limited data set, unique to your design project, and scale their objectives correspondingly. In training, bug hunting will require one more while improving coverage, a different one. However, within that limited scope, AI-generated models are very good at probing around challenging targets, a strength that proved to be enormously useful in mid and late stage design verification, sometimes even earlier. Popular use cases. The following examples highlight some of the more obvious wins in Virgin AI. Notably, we have also seen DV teams using the technology more broadly, for instance, in early bug hunting. Late-stage bug hunting. An experienced DV will flush out all the easy bugs and most of the hard bugs in a design through constraint random testing, perhaps complemented by some directed testing. However, some bugs, particularly those that turn up during, near, or even after the final sign-up regulations, are especially hard to hit. The sledgehammer defenses run many more randomized regulations with many more seed, with DV experts standing by the debug as the failure signature emerge. Late-stage randomized testing is very inefficient, even within the schedule and the budget constraint. The likelihood of hitting a new bug or a coverage bin is extremely low, and almost all those regression cycles will be wasted. That said, there is no denying the DV experiences that such testing will turn up a few new critical failure signatures. However, there are two problems. First, each new failure found requires a new time-consuming debug. As failure appears near sign-off, wouldn't it have been better to find those failures sooner, before you either sleep the schedule or add a list of the problems to fix in a slip bin? Second, what other failures might this low likelihood searching be missing? This is where Virgin AI shines. Say you've run a 20,000 simulation runs and hit 3 failures, two with one failure signature and one with another failure signature. The machine learning model can learn how using randomized tests could get into those extremely rare signatures, and from that knowledge, build a set of laws stress around those areas. What other failures might lie behind this new discovery? Late in the design cycle, this discovery isn't nice to have. It is critical risk management. We find this experience quite consistently, not always, but often. Using version sim AI, the teams expose failure signatures often before they would have been caught in regressions. They are still running those regressions to look for new rare failures, but they are augmenting them with targeted AI-based regressions, complementing their trusted process with the AI to accelerate bug discovery. Accelerating coverage closure. The slow track to coverage closure is familiar with the trial in DV. After the easy wins, maybe it takes 3 weeks for a team of DV engineers working every day to write and debug new tests. Trying to hit coverage means this is hard work. Under pressures, if the DV experts may over-constrain random generation in pursuit to that coverage, it happens. This is understandable in a tight schedule, but of course, the point of the added coverage is to expose more failures. Yet a very tight constraint can hide failures. Virgin Sim AI can complement the DV expert in coverage closure. It already knows about unhit pins and rarely hit pins, and by design, should significantly improve coverage across such holes, but not all holes. Virgin Sim AI automatically determines the correlation between rare coverage cases and specific holes, though you can supply a hint to help it along in some cases. If a hole continues to prove difficult to cover, a second step would be to check unreachability UNR analysis using our Jasper tool suite. Invariably, some holes still won't be covered. They will still have an important role in developing tests to attack these difficult holes. Nevertheless, we have seen the AI car-based coverage can cut DV development effort around the whole coverage in half. For a bounded optimist, there is a caveat regarding difficult coverage holes. AI can only learn from examples it has seen in training datasets. If your random test cannot enter a state region, then training starts with no guidance on entering that region. The generally will create tests around the boundaries of the hole, which fold accessible but not yet cover the holes. Will do a fine job in extending coverage. However, AMSs may not have better luck than the DV engineers if entry to the hole depends on a rare condition being satisfied. In short, Virgin Sim AI can be a very helpful complement to accelerating closure across the most of your design. If you remember that it's not a magical. Some verification problems, like how to access a hole, still depend on the ingenuity of the DV engineer to find a way in. If they can find such a path, it will be picked up in the training, and I can exploit it to boost coverage in that hole. Optimization regulations. DV engineers want infinite compute capacity and a more relaxed schedule to ensure they can nail every last bug. However, DV managers are held to much tighter constraints. They must work within a fixed budget and a tight schedule. The art of their job is optimized for the highest possible quality within these limitations. Optimization existing resources usage obvious win, especially in the large regulations that grow through design projects. We know that as the design stabilizes, those regression tests simply confirm that I have nothing new to report. Dropping those regression cycles would save a lot of time, which could be used to strengthen confidence through a new test development. Of course, you still want to run the full suit periodically to double check. Optimizing regression suite is not a new idea, and various methods, such as ranking, are popular and can work quite well. However, as with any automation software, such method depends on the trust from the DB team that the tool want to drive important tests from their regression suite. Sometimes there isn't enough time, resources, or experience with the tool to investment optimization. In practice, we see a spread in the optimization adoption, with opportunity for optimization ranging from some to quite considerable. What can Virgin Sim AI contribute to regression optimization? It has the obvious benefit of already being used across a much wider range of designs than any in-house regression optimization tool. Arguably, deserving a higher level of trust for that reason. However, it is still a tool and might optimize out an important test, so we recommend running for regressions weekly or bi-weekly. Confirm nothing important has dropped. That said, our customers see optimization learning from 5 to 10 times on average, and 10 times in some cases. Even for already well optimized suit, we still show 2 that 2 to 5 times improvement in runtime. Regression burn a lot of time and a lot of compute budget. What more could you do if the investment was cut another 2 to 5 times? Even though you think you already had this problem solved, how are the 5 to 10 times or more? More time for bug hunting, more performance analysis, and a few last-minute crises. Answering those opening questions, we posed several questions at the start of this article. First, can AI in simulation be trusted as a hands-free technology, or must you manually reconfirm simulations to verify its claims? The answer here is simple. For Sim AI, the simulation is run by the same simulation and constraint random generation engines you use usually in DV. Sim AI creates a new CR test, adding the more constraint on top of the constraint you have defined to define focus on a particular failure signature of coverage bin. It does change your existing test. The same engines, the same method you already trust. You just get some new targeted CR test based purely on learning from early regulation, nothing else. How much time does it really save? In a bug hunting, you're sifting failure discovery left. Would you eventually find these failures anyway? Probably, but don't you? But do you want to find them right before sign off? Earlier discovery allows for early resolution and a fewer crises. Most DB teams see that as a plus, as cutting DB development effort in half around closing coverage holds a win in coverage closure. DB manager will see this as a no-brainer. They will be able to assign more resources to debug. Finally, it's tough to argue that optimizing regression cycles by large factor is a bad idea. Regression is a big compute time sink. If you don't compromise quality, you will run full regressions periodically anyway. Why wouldn't you take advantage of this time resource saving? Can AI enhance the quality of the result? The answer here is clearest in bug hunting. AI lets you take advantage of the details level learning it has gained from the previous relation to zoom in around failure signature and low coverage beans with a randomized test, which will probe around those areas. Will this always expose new failures? No, but live experience indicate that it will often it that it often will. At a minimum, provide more information earlier, including new failure signature to guide the debug to root cause, and might even expose the new bug since at a later stage you're chasing rare failures. In summary, agentic AI simulation through Virgin unquestionably adds values with no need for hype. Today I read this article from Cadence. Thank you for your time. See you next time.